So, hello everyone. Today we will be talking about NetApp architecture, like how NetApp architecture works and how NetApp architectures look like. So, today we will be covering the NetApp architecture in this particular section or in this particular lecture. So, without any delay, let's get started. So if I talk about the NetApp architecture, then NetApp architecture consists of various kinds of features, and you can say various kinds of layers it includes in the architecture level. Why I am teaching you the architecture? Because architecture is very important before knowing the NetApp inside, or you can say before knowing the NetApp's protocols and before knowing the NetApp's commands and everything else, like how NetApp works. So basically, before knowing, before going inside the NetApp work, you have to just ensure that you know the architecture also, because architecture is one of the main thing that engineer, specifically NetApp engineer, storage engineer, must know how my NetApp works, what kind of protocols or does my NetApp support, what are the ports does my NetApp have, and what are all things that is very necessary for a storage engineer to keep in mind while configuring, or you can say while considering a NetApp uh, storage. Okay. So firstly, if I talk about the NetApp architecture part, then in our NetApp architecture, we have several kinds of things. Like firstly, we have our storage box. Okay. This is hardware, totally hardware, and it has some ports. Like firstly, for now, I am supposing it's an iSCSI port. Like you can also say it's an Ethernet port. So in my both nodes, I have two Ethernet ports. Okay, and along with that, I have one more management port also, which is also an Ethernet port. And based on that, we can have the SAS cables and etc. etc. That is totally dependent on model wise. So if I talk about the hardware part, then this is basically the NetApp architecture looks like from rear. Means from front, you can just assume like there are many drives of anything, any TB of drives, like you can suppose 1.6 TB of drive, single drive. So any drive can be included, or you can say inserted, means based on the model, like in which model you have purchased and what type of drives you are inserting. Like it could be an HDD, it could be an SSD, it could be NVMe also. Okay. So based on your NetApp, you can basically insert the drives. Okay. You can populate the drives. So if I talk about the NetApp's architecture, then I have my hardware part. It will consist of two nodes. This is my node one. This is my node two. Okay. So in my node one and node two, we have some ports, like I already mentioned over here. This is my Ethernet ports. This could be my FC ports, which basically consist of two sides, like you can say multi-mode, single mode. I'm making a multi-mode. Okay. Yeah. If we talk about the NetApp architecture now, then this basically consists of several ports, in which I am basically I am basically mentioning this is a FC port and this is the Ethernet ports. Okay. And after that, we have our management ports, means single management port, along with the, you can say, one console port, USB console port, you can say console port, USB console port. Okay, this is basically your hardware from rear. This is rear hardware. This is front hardware. Just pardon my drawing. Okay. Okay. So if I talk about now what actually the NetApp architecture is basically looks are like inside the software level. This is basically a hardware level. Basically, hardware level consists. One more thing I would like to just tell you in the architecture level, like you also have to know like what actually inside the one particular node. There is one particular section dedicated for the NVRAM. This is your NVRAM. I'm talking about the inside the node. Like what actually does a node contain? On your NVRAM, your boot media. The boot media basically consists your booting image. Okay. You will be consisting in the single node some DIMMs, NVDIMMs. Okay. This basically can be considered as RAMs, non-volatile DIMMs. Okay. You will be consisting some transistors. We can say you can also consist that is basically your motherboard inside your motherboard. Okay. Here is your totally motherboard, which basically consists of everything. This is your motherboard wall. Okay. Inside the motherboard, you have RAM, boot media, NVRAM, and your CPU. You have CPU. Okay. So this is basically your hardware part, like what actually the node contain. Okay. Now we will be talking about the software part, like how my NetApp architecture in the software terms looks like. Okay. So now suppose I'm just giving you one example. Like suppose you are just configuring, you just have configured an Ethernet, you can say iSCSI protocol or FC protocol based on your totally understanding. I'm just for an easily understanding. I'm just taking an iSCSI. Okay. Suppose you have configured an iSCSI configuration in the NetApp. Okay. Based on that, now you should have to know, or you should at least have a knowledge of that, like how actually the NetApp architecture performs read and write internally. What actually happens when a data is read? What actually happens when the data is written in the memory or in the memory and in the hard disks also. So, firstly, we will be talking about the writing part. Okay, like how actually the NetApp writes data. How NetApp writes data. This is a question. And today in the architecture part, we will be finding the answer of this particular question also. What actually exactly happens when an NetApp writes a data to the to the volume, or you can say to the hard disk. Like what? So whenever the suppose I'm creating a first layer. Okay, this is my first layer. I'm just mentioning it by first layer. This is my first layer. Okay. So in my first layer, I have different kinds of protocols. Like I'm mentioning one minute. Suppose I am mentioning this is an FC protocol. This is an iSCSI. This is an SMB. This is an NFS. Okay. iSCSI, NFS, FC. Okay. So after that, what will happen is my data comes from the host part. Like I'm just giving you one more example. Suppose this is my NetApp storage. Okay. And inside the NetApp storage, we have different ports. As we have already been discussing, like this is an Ethernet port, for example. And this is your server, you can say, which also have an Ethernet ports. Okay. So from that Ethernet ports, it is basically connected directly, or you can say you can also connect it through an iSCSI switch. Okay, iSCSI switch, or you can say Ethernet, ETH switch. Okay, done. And after that, what actually happens is whenever a particular write comes from the host part, like whenever a host, or you can say server, writes a data into the disk of a NetApp, or basically tells NetApp that this particular data you have to write in the disk, then what exactly happens is, firstly, it will check the protocol, like what exactly the protocol is. Like suppose if my protocol is iSCSI, then it will firstly check the ICE protocol in which basically NetApp is receiving from the HBA part, means from the network part, where exactly the protocol the NetApp is receiving. Firstly, it will check that. After that, it will go to the second layer. After checking like what exactly the protocol is, it will go to the second layer. This is basically your second layer. Okay. What exactly happened in the second layer is, second layer consists of one VLDB, okay, and after that it consists of CSM, okay. What exactly the VLDB is? VLDB is basically your volume database, okay. This is your volume database, and CSM is your cluster session manager, okay. I think you have, I'm very clear till the second layer. Okay. So first layer is consist of protocols, like what exactly the protocol the my NetApp is receiving from the host part. Secondly, my cluster session layer, or you can say cluster session manager, and VLDB takes a lead after the first layer. In second layer, my VLDB and cluster session manager comes into the picture. So in my second layer, we have already know the full form of our VLDB and CSM. VLDB means your volume database. CSM means your cluster session manager. What exactly happens is in the cluster session manager and VLDB? VLDB basically your volume database, which basically consists of your volumes database. Volumes database. Okay. What exactly this means? This means that this particular service, or you can this particular thing knows what exactly the volume is been called, what exactly the volume is been triggered, or you can say what exactly the volume is been compromised while basically uh, host is writing the data in the host is whenever a host is requesting a data to be written or to be read. Okay. So suppose, so it basically consists of your volumes information. Okay. So whenever a read comes, it basically tells like this particular read is basically for the aggregate third volume second. So this is what the VLDB work is in the second layer. Okay. Again, if again we will be talking about the CSM part. Like what exactly the CSM is. CSM basically does is basically make your sessions. Like as per the name, it basically clusters session manager. It basically manages your session manages by CSM. Like whenever you got a request from a one particular protocol, after that NetApp creates a session, one particular session, to which volume, to which aggregate, to that aggregate which VLDB has already suggested me that there my data is particularly in the that volume. Suppose if he suggested means VLDB suggested that my volume, my data sorry, the data that is been requested to be written in the aggregate, you can say, or you can say to the volume, or to the volume is basically in the aggregate 3 volume by this name. So this particular thing is consist of in the VLDB. So VLDB, what exactly tell you about the volume and aggregate thing, and after that CSM will create a session for that particular read and write, and it will automatically then send to your hard disk, HDD or SSD. Okay, I think this is clear to you. After that, my third layer comes. This is a very important layer in terms of a NetApp read and write. Okay, it consists of a RAM, NVRAM, and your engines. What exactly the engines is? You can say waffle engines, or you can say waffles. Waffle basically mainly consists in this part, or basically performs some important role in this part. Okay. In this part, you will also be getting get to know about the CP, consistency point also. Okay. So what exactly happened this layer is, in this layer, whenever data, my data comes to the network part, means what exactly the protocol is, my protocol. Okay. My protocol part. Secondly, it comes to the CSM and VLDB part. VLDV part. Thirdly, it will come to the third layer, that is a RAM or NVRAM or engine, you can say also the third layer. Okay, so what exactly happens in this layer is after processing protocol and CSM type of second layer, my data goes to the RAM. Okay, RAM what exactly does is it basically holds the data up to a certain time. Okay, during that time, what is exactly happening inside my third layer is it is basically performing a dedupe, compression, compaction, compaction. These things are performed in the third layer whenever data is written. Okay. After that, in the same time, whenever my data is processing in the RAM by these three engines, okay. And what exactly happens is NVRAM copies all the data into itself. NVRAM copies data. Okay. It basically copies all the data to itself. Okay. And after that, what exactly happens is this particular data is replicated to the second node and to NVRAM. Okay. During this time, whenever my RAM is processing the data in the terms of a deduplication, compression, compaction, what exactly happens is my NVRAM copies all the data into the into its random access memory. You can say for purposes or for the redundancy purposes, or you can also say for the uh, to make the data non-volatile. Non-volatile means suppose during this time my NetApp goes shut down, went shut down. So what exactly happens is your data, if not NVRAM is present, NVRAM is not present, my data will be gone, all gone. So to basically minimize this kind of things, what exactly happens is RAM after processing the data, or you can say RAM during the processing of data from the deduplication, compression and compaction part, what exactly happens is it basically uh, holds the data in the NVRAM. Okay, so that just in case if something bad happen, then the user data will not get impacted or compromised. Okay, so what exactly happens is it basically follows in my NVRAM follows one thing that is very I think is get to know thing, like it basically divides itself, means NVRAM, this is your NVRAM, it basically divides itself into two parts. I'm just writing it N1 and N2. Okay, my N1 part is 1 minute. Yeah. Okay. So this basically N1 means this basically holds the data. Okay. My N1 part holds the data and my N2 part also holds the data, but this part is basically used for replication into the node 2. Node 2 NVRAM. NVRAM. Okay. So what exactly NVRAM does is, or what exactly NVRAM follows is, it basically follows half full feature. Half full feature means whenever it basically halfly full means whenever my RAM, suppose it is of 8 GB RAM, 8 GB of NVRAM, whenever it got full by 4 GB of data, it basically perform a CP. What exactly CP is? CP means flushing the data to the disk. This basically your CP means whenever a particular time reaches, whenever my data dot is processed, whenever my data is processed from the deduplication, compression and compaction is, I will also tell you the compaction and deduplication in detail also, like what exactly that happens in the compaction or detail, compression and deduplication. I will be covering this also. So after basically performing the half full type of operation by the NVRAM, it basically does a CP, like consistency point. What exactly the consistency point is? Consistency point. What exactly the consistency point is? My consistency point is basically a snapshotting feature. Snapshot feature. Okay, you can easily mention or you can easily understand it by snapshot feature. Like it basically consists of a data that is basically of a one particular time. Okay, like whenever our node reboots, or you can say whenever our node got halted, it basically takes a snapshot. What kind of snapshot? A CP, consistency point, because during that time it could also happen like your data is processing, and it could also happen like your data you are about to receive a write request from the one particular host, and you just of all of a sudden closes your, or you can say shut down your, or you can say restart your NetApp. So during that time what exactly happens is a consistency point type of thing got triggered, and automatically it basically holds all the data in the NVRAM so that it doesn't get violated. Okay. So this is a feature that NetApp provides, and this is a very awesome feature that NetApp provides. And that is the only thing that I will like to mention in the waffle part. Like this is the only thing which basically differentiate NetApp from all other kind of storages. Like that's why the NetApp boots very quickly, not like other storages. NetApp basically boots very quickly because it basically revert all the settings from the last CP it has done from the before the shutdown, or you can say before the restarting of your NetApp OS. Okay, so whenever our NetApp reverts settings, it basically reverts from the consistency point that is that it takes lastly while before doing any kind of operation of like shutdowning and restarting. Okay, so this is what your CP is. Okay. So during N1 and N2 type of thing, like whenever our RAM performs N1 means in the N1 basically it holds the data. N2 basically is mainly considered as a mirroring type of thing. Like it basically considered as a firm mirror. Where to mirror? In N2 means node 2. Node 2 it basically mirrors the data. Just in case if my node 1 fails, then all the data from will be served from the node 2 NVRAM. Okay. So this basically happens in the NVRAM. Okay. Whenever my data is written in the RAM, after that it basically copies all the data to the NVRAM. NVRAM basically does is a half full type feature. Whenever all the things got cleared in the RAM, means deduplication and etc., all my data is basically flushed to my memory from the RAM, not from the NVRAM. This is one more thing I would like to tell you. Like NVRAM only holds the data, NVRAM only holds the data, only hold data for protection. I would like to clear this one thing to all of you. Like my NVRAM doesn't flushes the data to my disk. That particular thing is done by my RAM, because all the data is performed or all the data is basically processed inside the RAM, not in NVRAM. NVRAM basically provides you a non-volatility type of features. I think you are clear from my point. Like NVRAM. Let me write this one also. One minute. Okay. My NVRAM only holds RAM processes data. Okay. So this make this point clear. Like your NVRAM doesn't write the data to the disk. Only your RAM processes the data and writes the data to the disk. Okay. This is the one thing that everyone or every storage engineer who is basically using the NetApp should have understand. Like only your RAM processes the data. Okay. After that, what exactly happens at the RAM? So we have already covered about the NVRAM. So whenever the data comes into the RAM, it basically processes it to the NVRAM just for the non-volatility purpose. Like just in case my data doesn't get lost Means if something happened immediately during the processing of data. So after what exactly happens at the RAM is it basically does the what exactly happens in the RAM is it basically do the deduplication. Deduplication, as all we know, like if we have many data of same type, N1, 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 it will simply what exactly does it? It will only carry the N1, okay, N1 block and the reference of all the block to its memory means it doesn't delete the data. It doesn't delete the data. Deduplication doesn't delete the data, but keeps the reference of all the pointers that also holding the N1 data. Okay. And deduplication also are of two types, which we will be covering in my second lecture. After that, compression comes into the picture. Compression. Okay. Compression, what exactly does is it basically compresses the data. Like if you have a suppose you have done your deduplication and all these memory blocks are now not being used. So what exactly it does is it basically leaves the data or leaves the memory block as it is in the deduplication process, D2 process. What exactly done in the compaction part is compaction compresses the data up to its worth. Okay, means after deduplication, it basically creates a 4 KB of a block. And but how exactly the 4 KB comes into the picture in the NetApp is why exactly the baffle is of 4 KB of size. This will I also cover in my next lectures. Okay, we will be covering this soon. This is also a very important point. Okay, we will also cover why exactly the 4 KB only the block is created in the NetApp in the later lectures. Okay, so what exactly happens is after the deduplication is compression. Okay, it basically compresses the data. Suppose my deduplication does is suppose this is a 4 KB block. My deduplication make a reference of all the alternative blocks. Sorry. Okay, suppose this is N1, N2, N3, and 4. So my deduplication is basically creating a reference of these blocks. Okay. What exactly happens in the compression is basically doing the compression of these non written blocks, or you can say non preserved blocks, or basically rejected blocks, which basically or you can also understand by easily term is by after the deduplication these blocks value are left, means you can store the data over here. So what exactly happens in the compression is suppose this is my N1, which is basically the owner, you can say, or the main data that is basically left only by the deduplication, and all the rest blocks are empty. Okay. So what exactly happens in the compression is compression basically compresses the data and make it only 1 KB block inside the memory. Okay. So now my data is looking like this 4 KB block, and inside that only 1 KB. All the rest data is compressed. Another 4 KB block, and suppose another reduplication has run, so it create a 2 KB block. Okay, all the data has been compressed. Okay, it basically after compression it basically creates a 2 KB block. Okay, after that compaction comes into the picture. Okay, after that compaction comes into the picture. Compaction. Okay, what exactly the compaction is? Compaction basically runs after the compression. Means suppose in the 4 KB block there is only 1 KB of data is written and all of the data is compressed. Then what exactly the compression does is, and this is my second block. This is my first block. Okay, in this there is 2 KB of data. So what exactly the compaction basically insert this particular data inside that, making it a single 4 KB block. Like my data is in 1 KB and 2 KB, and still 1 KB is left. Okay. So this is what your compaction means, after which basically runs after the compression, and compression runs after the deduplication. So this is what exactly we have to understand in the NetApp's architecture, that how my data is basically read or written. Okay, this is today only I am covering the architecture part, and inside that architecture part we have one particular question: what exactly happens when the data is written to the memory, or you can say when the data is written to the hard disk inside the NetApp? What exactly the processor? Oh, sorry, what exactly the process? Exactly the process is, what exactly the things that happens inside the NetApps, and how NetApp handles various types of data with various with heavy load, with heavy IOPS. So this is what exactly happens inside the NetApp during the write operation in the third layer. In the fourth layer, in the fourth layer, this is my fourth layer. Okay. In the fourth layer, what exactly happens is your aggregate. Okay. Now here comes a VLDB function again, VLDB. After all the deduplication and everything performance like a deduplication, compression, compaction. Okay. My data goes to the aggregate, means the cluster session manager has already created a session for me based on the VLDB's location. Okay. So now, according to the cluster session manager and VLDB's locations, the data goes to the particular aggregate which basically has requested, or which basically requested by the host to write the data on. Okay. So based on that aggregate, and inside that aggregate, one that particular volume is compromised, or you can say triggered, for data return purposes and read purposes. Okay, this comes into the your fourth layer. Okay, and after that the RAID applies, the deduplication, sorry, RAID applies, and your parity is calculated. This basically comes into the fifth layer, your parity and all. Okay, this is how your NetApp architecture looks like. This is how your NetApp architecture works. Okay, in the same manner, whenever our read happens, what exactly happens is your data from the protocol. So this is your protocol now. Protocol layer, yani first layer. Okay. Firstly, it will identify the protocol. After that, VLDB and VLDB comes into the picture. Like what exactly the from for which exactly the volume the request is come from, and after that it will directly go to the aggregate part. If you have flash cache, then firstly it will hit the flash cache. And if the data is not present in the flash cache, it will definitely read from the aggregate, or you can say from the physical disk, or you can say your volume. Okay. After that, it will respond back to the host. This is how your NetApp architectures looks alike. Okay. So today I am ending this particular lecture, and we will meet in the second lecture.